Okay, so welcome back, and now we're going to do an example where we're given some information and we want to find parametric equations that represents the given situation. So let me read it to you and then we'll walk through it. It says, an object travels at a steady rate along a straight path from point -5, 3 to 3, -1 in the same plane for 4 seconds. Okay, so it travels from between these 2 points. So it travels from this point to this point in a straight line, going at a constant speed, and it goes from this point to this point in 4 seconds. Okay, now it goes on. It says the coordinates are measured in meters. Find parametric equations for the position of the object. Okay, so what they want us to do is they want us to find x of t and y of t that would represent the path of this object, the position of this object over time, or over these 4 seconds, right? Okay, so one thing to realize is that here's the starting point, right? This is our starting point, this is our ending point. And so the first thing we want to know is what distance is it traveling in the x direction and what distance is it traveling in the y direction. So in the x direction, it's traveling from -5 to 3. Now that's -5 meters to 3 meters. So its total travel, its total distance it's going is what? It's going 8 meters in the x direction. Okay, 8 meters in the x direction, and its starting point is -5. Okay, so let's think about this. So it's going 8 meters in 4 seconds. So its rate of change is 2 meters per second. This represents the slope, right? This represents slope of a line, right? With respect to time. So we can say x of t, so the x with respect to time has a slope of 2 meters per second, right? It's going at a slope or a constant speed of 2 meters per second times t, right? So which is going to give us meters, right? We want to make sure that the units are right, right? So 2 meters per second times seconds gives us meters, which is exactly what we want. Now, where are we starting at though? We're starting at -5. So our starting position is we're going to subtract 5 from each value. Okay, so this is like the y-intercept, right? So this is our starting point. So when t is 0, what do we get? We get -5, which is exactly what we want. Okay? Now, what about y? We can do the same thing in the y direction. We're starting at 3 meters, and we're going to end at -1 meters. So that's a total distance of 4 meters. So if you look at 4 meters divided by 4 seconds, okay? Oh, by the way, if we subtracted, if we went 3 minus -5, that gives us 8. So again, remember we have to do it in the same direction. So if you take 3 minus -5, that gives you 8. So in this case, you have to take -1 minus 3 gives you -4. Because again, the sign matters. Okay? So this is going to give us a -1 meter per second. And that's going to be, again, this is going to be the slope of this line. So this is going to be negative t, right? And then, of course, where are we starting at? We're starting at 3, so this is going to be plus 3. So when t is 0, we start with 3, and that's our starting point. So when t is 0, guess what? We get -5 and 3, which is what we want. Okay, so far so good. Now, what if t is 4, right? If t is 4, what do we get? We get t is 4, we get 2 times 4, we get 8 minus 5 is 3. Boom. And when t is 4 here, we get negative 4 plus 3 is negative 1. So we end up at the same point that they want us to, okay? So that's good. So now that tells me we did it correctly, okay? And now, is that all they want us to do? Let's see here. Yeah, that's pretty much all they want us to do. And then we could use these parametric equations, right? Let's just go one step further. Okay, so here's our t, x of t, and y of t. Okay? And so if we go from t equals 0, 1, 2, 3, and 4, what do we get? We get, of course, negative 5 and 3. And when t is 1, right? When t is 1, we get negative 3. And we get 2, right? And when t is 2, we get negative 1. And we get 1. So you can see a pattern here. This is going up by what? 2. And this is going down by 1. So this is going to go up to 1. And this is going to go down to 0. This is going to go up to 3. And this is going to go down to negative 1. Which is where we ended. Okay? And then we can use that information to graph it, but not only graph the line, but we know what direction the particle is moving along that path. Have a great day.